In chemistry, we learned that every atom of the same element has an equal number of neutrons and protons in its nucleus. But what if I told you that it's not true for every case? Some atoms from the same element can actually have a different number of neutrons. Those atoms are called isotopes. Today we will learn what an isotope is and why you should care about them. But first, this. Remember that a chemical element is represented by any of those 118 boxes on the periodic table of elements. Some examples are hydrogen, oxygen, nitrogen, and carbon. So let's look at carbon as an example. Carbon is element number 6. That number 6 is significant because it represents the number of protons in the nucleus of one atom of the element carbon. And that number 6 is referred to as the atomic number. You also probably remember that protons have a positive electrical charge. Now, every atom consists of a nucleus surrounded by a cloud of particles. That nucleus is composed of protons and neutrons. And those tiny particles in the cloud, well, those are electrons. Along with protons in the nucleus are neutrons. Neutrons are electrically neutral. That's why we call them, well, neutrons. And so they don't have an electrical charge at all. Now, the number of neutrons in an atom of carbon is equal to the number of protons. Carbon in its normal state has 6 protons and 6 neutrons. Now, 6 plus 6 is 12, and that number 12 is the atomic mass of one atom of the element carbon. Note that atomic mass can also be called atomic mass number, or nucleon number. So this is probably the best way to define what an isotope is. Isotopes are variants of a chemical element that differ in neutron number. In other words, isotopes or nuclides of an element have the same number of protons in their nucleus, but different numbers of neutrons. So normal carbon, remember, has 6 protons and 6 neutrons. Normal carbon's atomic mass number is 6 plus 6, or 12. And this form of carbon with a mass number of 12 is referred to as carbon-12. Carbon-12 is the most common and stable form of carbon on Earth. Now, if we call it carbon-12, that number kinda tells us that there should be other types of carbons in this world. And guess what? There are. There is carbon-13, which is an isotope of carbon-12. It is a very stable isotope of carbon. It occurs naturally, makes up about 1% of the carbon on Earth, and as the name shows, the atomic mass of carbon-13 is 13. Now, one question for you. Can you guess how many protons are in a nucleus of carbon-13? I will wait. And time is up. The answer is 6, of course. I can see you have been paying attention to this video and not watching another awkward dance video on TikTok. We know that all isotopes of an element have the same number of protons, so carbon-13 has 6 protons in its nucleus. Now the question is, how many neutrons are in a nucleus of carbon-13? And if we do the math, 13 minus 6 equals 7, right? So a nucleus of one atom of carbon-13 has 7 neutrons. And because there is no change in the number of protons, the electrical charge doesn't change, and an atom of carbon-13 is neutral, just like an atom of carbon-12. With that in mind, I need to highlight an important fact right now. All isotopes of a particular element are chemically neutral. If carbon-13 has 7 neutrons, then how many neutrons does carbon-14 have? Well, again, quick math. 14 minus 6 protons that we have in the nucleus will equal to 8 neutrons. So the nucleus of one atom of carbon-14 contains 8 neutrons. Like carbon-12 and carbon-13, carbon-14 occurs naturally. However, even though carbon-14 is electrically neutral, remember the number of protons hasn't changed, so the atom's net charge is still 0, the extra neutron makes carbon-14 unstable, and therefore radioactive. We call these radioactive isotopes radionuclides. Carbon-14, while radioactive, is not a useless isotope at all. You see, because of its instability, carbon-14 breaks down over time. And because of that, carbon-14 becomes a useful tool in radiocarbon dating. Radiocarbon dating, or carbon-14 dating, is a method for determining the age of organic material, like a dinosaur bone, by using the unstable properties of carbon-14. Carbon dating was developed by American chemist Willard Libby in the 1940s. The term isotope comes from the Greek words isos, meaning equal, and topos, meaning place. The word isotope literally means at the same place and refers to the idea that different forms of the same element, like our old friends carbon-12, 13, and 14, occupy the same position on the periodic table. English radiochemist Frederick Soddy suggested the existence of isotopes way back in 1913. Soddy won the 1921 Nobel Prize in Chemistry for his work on isotopes. Carbon is not the only element with isotopes. In fact, there are 254 known stable isotopes. Besides carbon, some others that you may know include hydrogen with its 3 stable isotopes, oxygen with its 3 stable isotopes, and nitrogen with its 2 stable isotopes. Some elements have more than 2 or 3 isotopes. For example, tin has 10 isotopes, xenon has 8, 4 elements ruthenium, dysprosium, ytterbium, and mercury each have 7 stable isotopes. There are more than 3,000 radioactive isotopes or radionuclides. However, only about 84 of them occur in nature. The others have been artificially produced through various nuclear reactions. Radionuclides are quite useful and have many applications, like in medicine. For example, nuclear medicine involves the use of radioactive isotopes. For example, technetium-99 is injected or swallowed as a pill by the patient to assess the functioning of various organs or to even assess bone growth and formation. I couldn't finish this video on isotopes without briefly talking about half-life. Half-life is the time it takes for a quantity of an element to be reduced by 1/2 as a consequence of decay and therefore the emission of radiation. Carbon-14 is an excellent element to use in carbon dating because its half-life is only about 5,730 years. And during beta decay, carbon-14 becomes nitrogen-14. When organisms die, they stop producing carbon-14. Since half-life is a constant, the ratio of carbon-14 to nitrogen-14 provides a measurement of the age of a sample. There are some stable isotopes that don't decay at all, and some isotopes that take ages to decay. There are about 34 isotopes that have half-lives of more than 100 million years. Wow, can you imagine? These elements have been around since the formation of our solar system, and they don't look a day over infinity. We call these long-lived isotopes primordial nuclides. That is it for this video. I hope you enjoyed it. Don't forget to subscribe and like it if you would like to see more of these videos in the channel. Until then, I will see you next time.